Good morning, students. Welcome back to science class. Today we shall start a new chapter, that is gravitation. Okay. In the previous class, we had discussed some problems related to kinetic energy, potential energy, and power. Okay. So that chapter is also over. So finally, we have completed 3 chapters. Okay. Today or tomorrow, I will send one link in your WhatsApp group. So there you have to attempt that test. Okay. Test means multiple choice questions. Okay. 15 or 20 multiple choice questions. Uh, you have to attempt that test. Okay, so while attempting, first you have to enter your name. Okay, then Gmail ID, then your WhatsApp mobile number. Okay, WhatsApp mobile number, you have given that number to your WhatsApp group, right? So that number you have to enter. Okay, yes, today we shall study gravitation chapter. See, in the motion chapter, we had studied uh, about motion, right? How objects move, and how velocity can changes. Okay, so we had discussed acceleration, speed, average speed. Okay, in the second chapter, we had discussed the actual cause for change in velocity, or change in direction, or change in speed, or change in momentum. Okay, so in this chapter, we shall study, for example, take this marker. If I release this one, okay, if I release it, what will happen? It will fall down. Okay, why it will fall down? See, see this object, it won't move itself. Okay, so when you apply a force like this, then only it will move. Okay, see, if you won't apply force, then it will stay here only, it will remain at the rest only. But when you drop like this, when you drop this marker, what will happen? It will fall down. Okay, why? See, actually I am not applying a force, right? But still it will fall down. Okay, so what is the answer here? So, what you are studying the second chapter, in inertia. If there is no force, if one object is at rest, it remains at rest only. If it is in motion, it remains in motion only. Okay, but here I am not applying any kind of force. When you drop some objects from a certain height, all the objects, they will fall down. Why? Yes, so that is due to the gravitational force from the earth. Okay, that earth, it attracts the objects, right? So there also some kind of force exists. Okay, so that force is known as gravitational force. Okay, so in this chapter, first we will study what universal law of gravitation, and why objects attract each other, why objects, when you drop some objects from a certain height, why they will fall down, and we'll study the importance of gravitational law, and we'll study the relation between, difference between mass and weight, and also we shall study what is thrust, force, then conditions for floating objects in fluids. Okay, first we will study gravitation. We all know that moon goes around the earth, correct? Moon goes around the earth, and all the planets go around the sun. Clear? See, why, all the planets are there, see, every day just they are keep on revolving, right? All around the sun, and moon is just keep on revolving around the earth. Why? Once Newton, while having a tree, one apple fell on him. Okay, so that fallen, for him, it started to think. Okay, why that apple fell down? Okay, what is the reason here? Then he concluded that, so here that apple fell on his head. Okay, so he said that, he argued that some kind of forces exist. Here earth attracted the apple. Okay, so some force exists between earth, apple, and earth. Okay, so some force we don't know. At that time, he doesn't know that one. Okay, he did know that one. Next, then so this is earth, and moon. So moon is also revolving around the earth. So at last he said that while falling an apple, okay, he said, right, one some force exists here. Okay, so that's why that apple fell on the earth. Then here also the moon is revolving around the earth. So then he said that the same force exists between earth and moon and apple and the earth. The same force. Okay, but see here, if same force exists between apple and earth and moon and earth, here this apple which fell towards the earth, right? Here that earth attracted an apple. But what about here? See here we never see, right? The moon is falling towards the earth. Okay, but he said that the same kind of force exists between here in this case and in this case. Okay. See, then later he said that what at each point of its orbit, at each point of its orbit, okay, at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. Okay, instead of going in a straight line at each point, okay, at each point its orbit, the moon falls towards the earth. Clear? See here in this case and in this case the same force exists, but here earth attracted an apple, but here earth is not attracted the moon, but the force remains in both the cases same. Okay, and here in each and every point moon falls towards the earth. Clear? But we do not really see the moon falling towards the earth. Okay, what is the reason here? Here, if you know the answer, please put it in the comment box. Okay, see here, at each point moon is falling towards the earth, but we do not really see that moon is falling towards the earth. But here apple, here the earth attracts the apple. Okay, but here and here the same force exists, but here an apple is moved towards the earth, but here the moon is not moving, the moon is not falling towards the earth. Okay, if you know the answer, please put it in your comment box quick. Just to take one thread and tie one stone. So start the rotate like this. Okay. See here you are rotating the stone and thread. Okay. Here what will happen? It will start to rotate in a circular motion. Okay. So in a circular path, we call this as circular motion. See here, when you release the thread while rotating, just imagine you are rotating. At this point, you will release that thread. What will happen? Then this thread, it will move in a straight line. Okay, when you release that one, what will happen? It will move in a straight line. Suppose that thread is here. Sorry, that stone is here. At that time also, you will release that thread. At that time, what will happen? So here also, it will move in a straight line. Okay, suppose the object is here. Straight line like this. Then suppose the object is here. At that time, it will move in a straight line. Okay, and the object is here. It will move in a straight line. Okay, next, just the object is here. Then it will move in a straight line. Okay, see see, wherever if you release that thread, what will happen? So then that when you release that thread, then that stone it will pursue in a straight line motion. It will move in a straight line. Okay. So which means what it indicates, while rotating at each and every point, and each and at every point you are changing or you are pulling towards the center. Okay, means you are changing the direction. It is moving in this direction. You are changing the direction at each and every point. Okay, so that's why it won't go in a straight line. Are you getting my point? Here, continuously you are changing the direction of the stone. Okay. Now, see here, while rotating continuously, see the stone is, it remains here only, right? It won't come towards the center. Why? Why? Because you are applying a force. Okay, here giving some force. So that's why that force which keeps the stone in a circular path. Okay, so you are applying that force through this thread. Clear? So that force which keeps the stone in the circular path. So that's why it will rotate continuously. Okay, when you release, when you stop the rotation, what will happen? So it will come towards the center. Correct? Yes. So here you are giving the force through the thread. Now just think in this case, moon and earth. Okay, so here do you think that is there any thread between earth and moon? No, right? Okay, so here see, due to some force here, due to some force, that force which keeps the stone in a circular path. Correct? So but what about here? So here also one force is there, that force which keeps the moon to revolve in a circular path. Okay, so that force is called gravitational force. Okay, so here the centripetal force here. Okay, here the center seeking, because here changing the direction of moon continuously, right? Okay, so we call that force as centripetal force. Okay, so here we are changing the direction of the stone at each and every point. So that's why that force which keeps the stone in a circular path. But here also, due to the gravitational force, okay, which keeps the moon to rotate in a circular path continuously. Okay, suppose just imagine if you remove the earth, what will happen? If you remove the earth, then that moon it will move in a straight line. Okay, so due to the gravitational force, that gravitational force which keeps the moon to revolve around the earth. Okay, so clear, right? Now the same concept in solar system also. So all the planets are revolving around the sun. So there also, due to the gravitational force, all the planets are revolving around the sun. Okay, see here. See here, and next one more thing. Later, Newton he said that in this universe, all the objects attract each other. All the objects attract each other. For example, say take two objects A and B. Okay, maybe after some time, for example, you are keeping both the objects in a space. So after some time, both the objects will attract each other. Okay, so he said that all the objects attract each other. For example, just imagine I will keep one table here and I will keep these two markers. So if you come tomorrow or after 1 year or after few years, do you think that both the markers will attract? No, correct? But he said that in this universe, all the objects attract each other. Okay? Here, after some time, both the objects will attract each other. But here, these two objects are not attracting, right? Why? Because here, that is due to the gravitational force and due to the frictional force. Both the objects are not attracting. But if you keep two objects in the space, okay, in the absence of external forces, in the objects of external forces, if you keep two objects like this, then both the objects will attract each other. Okay, he said that. So what is that? In this universe, all the objects attract each other. Okay, now see here, in this case, an apple and earth. Okay, here earth attracted the apple, right? Not apple attracted the earth. Clear? In this case here, apple, see here, earth attracted the apple, not apple attracted the earth. Correct? But here, every object attracts each other. So that attraction, that force of attraction, which depends on the masses of the objects. See here, the mass of an apple in front of the earth, it is complete very less, right? It is negligible. Okay, see, even our mass also it is negligible. Okay, in front of earth, because it's very small, because earth's mass is it's very huge. Okay, so that's why that force of attraction which depends on the masses of the earth. So here mass of the earth is more, so mass of the apple is very small, so that's why earth attracted an apple. Okay, so here in this universe, all the objects attract each other. Okay, so that force of attraction, is directly proportional. That force of attraction is directly proportional to the product of the masses of the objects. I will take this mass as m1 and this mass as m2. Okay, so here this force of attraction is directly proportional to the product of their masses, that is m1 into m2. Okay, which means if you increase the masses of the object, then the force of attraction increases. Okay, if you reduce the masses of the object, then the force of attraction reduces. Okay, next one, this force of attraction also inversely proportional to the square of the distance between them. So I will take the distance between from center to center. Okay, so here we should take the center, here we should take the distance from the center of the objects. I will take that distance as d. Okay, so now the force of attraction which is inversely proportional to 1 by d square, or square of the distance between them. Okay, the force of attraction is directly proportional to the product of the masses of the objects, and inversely proportional to the square of the distance between them. Okay, so now call this equation as 1 and this equation as 2, which means here if you increase the distance, then the force of attraction reduces. If you reduce the distance, then the force of attraction increases. Okay, so by combining 1 and 2, we can write F is equals to m1 into m2 divided by d square. Okay, so now we should remove this proportionality symbol, right? So here for that we should introduce one concept, that is F is equals to g into m1 into m2 divided by d square. Here g, in this equation F is equals to, you have studied, right? F is equals to m into a, that is F is equals to, you have written k into ma. Okay, so here also same, F is equals to g into m1 into m2 divided by d square. Here g is known as universal gravitational constant. What is that? G is known as universal gravitational constant. So here that G means the minimum force. If you take two objects, some minimum force exists between two objects. Okay, so that force is known as universal gravitational constant. Okay, see here what is G? Here G represents universal gravitational constant, and it has a standard value. It has standard value that is 6.67. Right here, G is equals to 6.673 into 10 raised to the power minus 11 minus 11 minus 11 Newton meter square and per kg square. Okay, why? Because see here, this is the value. When you bring this side, what will happen? See here, we can rewrite this equation as F into D divided by M1 into M2 is equals to G. Here F essentially F is Newton, and here D. Now this is a D square, right? That is essentially is meter square, and M1 kg, M2 we measure the masses in kg, right? Kg into kg, that is divided by kg square. So per kg square. So this is the value of universal gravitational constant. Okay. So what is G here? Capital G. So that capital G, which represents the universal gravitational constant. So clear, right? So now tell me. So now we can define that universal of gravitation in a systematic way. Okay. So now we can define that gravitational law. See, every object in the universe, every object in the yes, yes. Next move to importance of the universal law of gravitation. Okay, see the importance of this universal law of gravitation. So first one is force that bind us to the earth. Okay, so this is the first importance of the universal law of gravitation. What is that? The force that binds us to the earth. Then second one, the motion of the moon around the earth. Right, first one, then see first one, the force that binds us to the earth. Second one, the motion of the moon around the earth. Okay, the motion of the moon around the earth. The motion of the motion of the moon around the earth. Around the earth. Next, around the sun. Next, okay. So importance of the gravitation law. First, reasons. Okay, why we are living Earth? Why we? Okay, so first one is the force that binds us to. Then we got a reason why the moon is moving around the earth. Okay, so that's why the motion of the moon around the earth. So here the moon is revolving around the earth, right? Why? That is due to the gravitational force. Okay, next one, the motion of the planets around the sun. The motion of planets around the sun. The motion of planets around the sun. Next, one more is there. Tides. Okay. The tides due to the moon and the sun. The tides Now you can see the tides in the sea, right? The tides due to the moon and sun. See, these are the importance of the universal of gravitation. Okay, we got reasons for these questions. Okay, why we points to the earth, then why moon is moving, why the moon is moving around the earth, and why planets are moving around the sun. Next, the tides due to the moon and sun. Okay. Yes, sir. Next, move to free fall. Okay, so free fall. Now, see, when do we say that an object is in free fall? Okay, see that word which gives free fall. For example, see, now if you drop this marker, so I can, when you drop, after dropping this mark, I can say that marker is in free fall. Okay, then what is the free fall? Okay, so free fall means when the objects are under the influence of, okay, see here, when the objects are under the influence of gravitational force. Are you getting my point? When the objects are under the influence of gravitational force, so then we can say that those objects are in free fall. Okay, so when the objects are under the influence of gravitational force, so here when you drop all the objects, those all the objects are falling due to the gravitational force, right? Why? Because earth, so earth is attracting the objects. Okay, those objects are under the influence of gravitational force, so then we can say that those objects are in free fall. Okay, if an object under the influence of gravitational force, so then we can say that that object is in free fall. Okay. So I will stop here. Tomorrow I will continue the class, and I will give one homework. Okay. So this is a lengthy problem. So without seeing your textbook, just try it. Okay, yourself. So we'll discuss in the next class. First I will write the problem. See, this is the homework for you. Yes, here Shankar Gowda here. So what about the students who are not in the group, sir? How we should attend the test? So here, please send your phone number to my WhatsApp number. Okay, I will add in your group. Clear? So please send your WhatsApp number to my number. Okay, so I will add your number in the WhatsApp group. See here, so in today's, so this is a homework for you. Okay, it's a lengthy problem and it's a little bit difficult. Means here, difficult means it's a calculation. Okay, so without seeing your textbook, so just try it. If you won't find the answer, so we'll discuss tomorrow. Okay, see, in today's class, we have discussed what is the reason for why the moon is revolving, why moon is revolving around the earth, and why planets are revolving around the sun. Okay, so we'll continue in the next class. Thank you.